Saints, so we're going to get started on lesson 9.7 here. Make sure that I have my other screen not. There we go. Put the volume off. So let's actually talk about the law of sines and cosines. So this is going to get back to the problem that we did in class and that I suggested at the end of the last lesson. But I'm going to do a quick algebraic proof for you guys, and it's a slash graphical proof for you. Let's take a triangle right now, and this is just any triangle ABC. Right? So I'm going to go ahead and take my auto shape off. My shape drawing tool. I want to make sure. Ooh, goodness. Yeah, good. Got my calculator still working here from class. So what I'm going to do here is I'm going to identify a few parts. For example, if this is not a right triangle, but still, we're going to relate angle B and note that it's going to be for this side opposite. B is going to be lowercase b. And for angle A, the side opposite is going to be side A. Okay? So, what we're going to do inside of triangle ABC is that we're going to draw CD as an altitude. Now, we had, when we created, for example, when we had a right triangle and we took an altitude, we had 3 similar triangles. Now, we don't have to worry about the triangle similarity here. That's not going to be really the issue. What we're going to do here is that we have this height h. And I have 2 different triangles I'm now considering that are right triangles, and I can use some trig. I have this triangle over here, CBD, and then I have this triangle over here, ADC. And I'm going to point out something here. So, from the angle, remember, from A, the sine of A, remember, is going to be the opposite, this side H, over the hypotenuse, which is this side B, all right? So this is going to be equal to H over B. Now, simultaneously, from the angle, so from angle B, again, I could develop the same a ratio with sine, where that the sine of B is going to be equal to the opposite side H over the hypotenuse, which is A. Now, here's something that we can do, is that we can actually solve for this common side H algebraically. So what I would do, and I'm just going to rewrite this, that I'm going to have B times the sine of A is going to be equal to H, right? If I multiply both sides by B, all right? And then same thing's going to happen on this other side, where I'm going to have A times the sine of B equal to H. Now, take a look at this algebraically. Both things are equal to H, so therefore they are equal to each other. So then what I can do is that I can say that B times the sine of A is equal to A times the sine of B. Now, I can do a little algebraic work here, and let's say that I want to divide by A on both sides, right? Just to get the A's all collected over here. And if I do that, that's going to factor these guys out, okay? And then simultaneously, I could also divide by B on both sides, right? Because as long as I do it to one side, I'll do it to the other. So it's going to factor that out on the left. So what I'm left with here effectively is this, is that I'm going to have what is now known as the law of sines, that I have the sine of angle A over side A, which is equal to the sine of angle B over side B. And you know what it'll actually extend to? I could conclude with doing the same exact process for side C, or an angle C up here, okay? But instead, just have this. Here is what is known as the law of sines. Well, you have to memorize this for your next test, and the answer is yes. Now, SOHCAHTOA, I think, especially after our last class, probably have memorized forever. And then now the law of sines is something that we're just going to have to remember, okay? Sine of A over A is equal to sine of B over B, which is equal to the sine of C over C, which means we actually can utilize this on non-right triangles. So, here's what we'll do. If we have the measure of angle A is 17, and the measure of angle B is 29, and A is equal to 8, then how long is side B? Okay. Well, let's just use the law of sines then. All right. Uh-oh. And it's having a little malfunction here. Here we go. So, remembering the law of sines, the sine of A over A is equal to the sine of angle B over side B. All right. And now I can just substitute. It's going to be the sine. And then we have for A, 17 over lowercase a, the side, which is 8, which will be equal to, and look at this, guys, I'm actually completing this, and I don't even have to see a visual for it. I have all the information for all of, for the completion of this. The sine of b, which is 29, over, and then we're going to solve for lowercase b, okay? So, next step, let's take a cross product, okay? So I'm going to have b times the sine of 17. And remember, sine of 17 is just some number, right? Like if we go into the calculator, we can actually just, punch in sine of 17 and it's some decimal number. So I can divide by that entire term and it's just whatever that 0.292 blah, blah, blah thing is, right? So getting back to it, b times the sine of 17, and then we have 8 times the sine of 29, and I got to get b by itself. So how do I do that? Well, I'm going to go and I'm going to divide both sides by the sine of 17, because this is just some number, right? And I can, again, it's okay as long as I do it to both sides. And then these will factor out. So b will be exactly equal to whatever the result of 8 times the sine of 29 over the sine of 17. Okay? Now, let's go punch that into a calculator together. So we have 8, and that was times the sine of, my notes here say 29, okay? And that's going to give me that number, 0.38748. Now, what I can do here is if I just hit divide right now, it's going to already grab that previous answer, okay? And I'll show you guys another way to grab that answer too. So it automatically just put in the numerator 3.8784, etc., etc. And then I need to divide this by the sine of 17. Okay? And that will give me about 13.26. And remember that we're going to round these to the nearest tenth for a side. So B is about equal to 13.26, which is 13.3. And I, of course, need both of these. Okay. So let's do another one. Got 2 more examples for you guys today. I'm lying. 3 more examples. 2 that we'll get after. We'll solve part of an angle. We'll solve a triangle. And then we'll actually look at the problem that we had yesterday. So we find the measure of angle A in triangle ABC. If C is equal to 7, A is equal to 9, and the measure of angle C is equal to 43. Okay? So this works just all the same. That, remember, the sine of the angle, right, is over, there's a ratio over the side opposite is equal to the sine of whatever other angle. In this case, we have angle C. Okay, so we're working with A and C over lowercase c, and then now we just plug and play, right? So it's going to be the sine of A, because we don't have that, but we have lowercase a, which is 9. We have sine of C, which is 43, so sine of 43. And then lowercase c, which is 7. All right? And we'll take our cross product. So, doing the cross product. Oops, don't want to erase that. I have 7 times the sine of A. And now, before I actually finish my cross product, it's kind of like, well, why multiply right? And do a cross product when I could just do the following. Can't I just multiply by 9 on both sides? And then get sine of A by itself? And then A isn't by itself, but you guys, I think, already know what we're going to do. It's going to be times the numerator here. 9 times the sine of 43 is going to be all over 7. And then I got to get rid of this. And of course, you guys know how just frustrated I get when you guys want to divide because we can't do that. In order to get rid of that A, that's that sign on this side, we're going to have to take the inverse. So angle A is going to be equal to, and we're going to take the inverse sign of this entire fraction, 9 times the sine of 43, and that's going to be all over 7. All right? Let's go ahead and punch that into a calculator. It's a lot of stuff to punch in, okay? Should work, though. I'm going to go ahead and circle my answer, my exact answer. Go back to my calculator. And I'm going to try to do this all in one shot here. Let's see how we do it. We have the inverse sign, and now we're going to put everything that I have in the parentheses. And so in the numerator, let's see if this works. We'll have 9 times the sine of 43, then we'll close the parentheses, and then we're going to divide that entire thing by 7. And I'm kind of curious if it's going to get the order of operations correct. Now I have to close my parentheses from when I started the inverse sign. And then this one gave me 61.26, which is actually correct. So the Texas Instrument calculator actually handled the order of operations pretty well. You may have to actually do the following, where you're going to have to take the sine of 43, okay? And then you're going to have to multiply by 9, okay? And then you'd have to divide by 7. And then you have this decimal number, right? And what I can do is I can take the inverse sign, so second sign. Now watch what I'm going to do here. The next to the enter key, if I go second to the negative right here, you guys are going to see that it's going to be answer, okay, ANS. So the bottom right corner, so second answer, and it grabbed that previous answer here, that 0.8764, and it put it into there, and if I hit enter, that gives me the same thing, 61.26, right? So this is going to be, to the nearest degree, angle A, which is about equal to 61 degrees, okay? So let's solve a triangle. And then I'm going to pose a question for you guys, all right? So now, we're going to solve triangle ABC. Given the measure of angle A is 112 degrees, measure of angle C is 8 degrees, and lowercase c is 2, all right? First thing I'm going to do, solution box. So let's think about the parts that we do not have here. What am I missing? Well, I have A, side A, but I need lowercase a. Let's see what that's about equal to, okay? I have side C and angle C, but I don't have angle B, and I don't have side B. All right? And I think we're going to get some approximations here, okay? Or maybe not. Maybe where you can figure out what angle B is, because due to this, right, we can actually solve for B by doing 180 minus 112, right? Which is what? 68. And then I'm going to subtract another 8 from that too, right? Wasn't that what also I'm going to wind up doing? This was 68. And we have that minus 8 to get 60. So that's angle B. Have it directly, okay? Cool. Let's go ahead and solve for lowercase a. So I'm going to take the sine of A. So I'm going to just plug it right in. The sine of 112 over A, which is what I'm going to solve for. And then I've given these parts for C. So I'm going to take the sine of C, which is 8 over 2. Now, could I actually go in here and put in the sine of 60? Well, then I'm also looking for B anyway, so I can't do that, right? So I have to do it this way. I'm going to take this as the sine of 8 over 2, all right? Now I got to for sure do a cross product, right? Because it's, otherwise I'm going to I get the right thing here. So I have 2 times the sine of 112 is equal to a times the sine of 8. And then I've got to get a by itself. So I'm going to divide both sides by the sine of 8. Because remember, the sine of 8 is just some number. So that's going to factor out. So a is going to be exactly equal to 2 times the sine of 112 over the sine of 8, which we're going to go to our calculator. 2 times the sine of 112. All right. And we're going to divide that by the sine of 8. Let's see what we get. 13.3, which is correct, right? So let's go to our solution box and record A as 13.3. All right. Now, let's get B. So we already know what B is, which is 60 degrees. So we're going to take the sine of 60 over lowercase b. Now, could I do the sine of 112 over 13.3? Okay. Could I do this right here? Well, you could, but the issue is this is going to give you that approximation of approximation we've discussed before. So a better way to go about this, as long as we can, is we'll use C, right? And it's excellent. It's available to us. So we'll do the sine of 8 over 2, okay? We do our cross product, just like we did before. And then we're going to have 2 times the sine of 60, okay? Is going to be B times the sine of 8. And then you need sine of 8, sine of 8. So there you go. B is equal to 2 times the sine of 60 over the sine of 8. That is the exact answer, but we're going to actually go again, try it in the calculator. So we have 2 times the sine of 60 divided by the sine of 8 in my parentheses, and that gives me about 12.4. All right. Awesome. Very cool. So let's go back one more problem here that we did earlier in our last lesson, and it was this guy. All right. So I'm going to cut all the stuff right here. So copy this. Let's get back over here. I'm going to paste this whole thing. Okay. Now I have this right here. The question is, can I solve this triangle? Okay. Could I use the law of sines? And that's the last thing I'm going to leave you with as we finish up today. And I will ask you guys the same thing in class. I'm curious what your answers are going to be.